Now let us look at our first example on the board. The question is, if the volume of a fixed mass of hydrogen in a container is 30 centimeter cube at a pressure of 50 millimeter mercury, find the volume of the gas if the pressure is 60 millimeter mercury at constant temperature. Now, if we are to look at this question, the first thing you need to do is you should be able to collect your data. Now, what are your data? Now, the first thing we're given there is that they gave us the initial volume. So you now say that initial volume, which is our V1, is equal to 30 centimeter cube. We're also given initial pressure. So the initial pressure, which is P1, is equal to 50 millimeter mercury. Then we're given the final pressure, which is the second pressure there, which is P2, is equals to 60 millimeter mercury. Now we are asked to find the final volume. So the final volume, which is V2, is what we are looking for. Now, what is our relationship as established earlier? We say that it is what? P1 V1 equal to P2 V2. Now, by the time we make our V2 the subject formula, we should have that V2 is equals to P1 V1 all over what? All over P2. So by the time we substitute into this formula now, we should have P1 is what? Is 50 times V1 is what? Is 30 divided by P2 is what? 60. So by the time we have V2 is equals to 50 times 30 should give us 1,500. So by the time we divide 1,500 by 60, we should have that our V2 is equals to 25 centimeter cube. So this is the answer to the final volume. That is, if the pressure changes from 50 millimeter mercury to 60 millimeter mercury. All right, let us look at the second question on the board. We're told that if the final volume of a gas is 1/5 of the initial volume, find the ratio of the final pressure to the initial pressure at constant temperature. Now, the first thing we need to do is for us to collect our data. So that means we have that our initial volume is equals to V1. Then we're told that the final volume is 1/5 of the initial volume. That is V2 is equals to 1/5 times what? Times V1, which will give us V1/5. Then we have our initial pressure. We have our initial pressure to be P1 and our final pressure to be what? P2. Then our relationship remains that P1 V1 is equals to P2 V2. So having done this, now the question is for us to find the ratio of the final pressure to the initial pressure. So by the time we make that mathematically subject of the formula now, we should have that our P2 over P1 should be equal to V1 all over V2. So by the time we substitute the value into the formula now, we should have it that our V1 divided by, now what we have as V2, V2 is V1/5. And you also know that mathematically this is the same thing as saying V1 times 5 all over what? V1. So this and this we cancel, we have 1 here. So at the end we are going to have P2 over P1 is equals to 5 all over 1. So we can now say therefore the ratio of final pressure to initial pressure, which is P2 ratio P1, is equals to 5 ratio 1, which is our answer to this particular question.